In today's video, we're going to be learning how to make a coin collection system. Now, on the surface, this sounds very simple, but I think by the end of this video, you're going to learn a lot of valuable lessons. So essentially, how this coin system is going to work is there's going to be a couple of spawn locations for these coins. And also, there's a variety of different coins. We have a bronze, silver, and gold coin, and the primary difference between each of them is, of course, their color, but also the amount of money that they reward the player with. So when we go ahead and touch a bronze coin, we can see that it slowly disappears, and we're also rewarded with some coins. Now, the bronze coins only actually give us about 1 coin, whereas the silver gives us about 5, and then the gold gives us 10. So that's a quick showcase of the system, but from that alone, you can clearly see that there's a little bit more to this system than just collecting coins. Now, before we begin, in order to save us a lot of time, we're actually going to be starting off by using my own personal game template, which I'll leave a link down below in the description to. Once you visit this link on the game page, you're able to click the 3 dots right here and then click Edit in Studio. And then that should open up the game directly inside of Roblox Studio for you. Now, if you're unfamiliar with this game template, essentially it includes the module framework, which allows us to write all of our logic inside of module scripts, a UI scaling script, which will automatically scale UIs to all device sizes, the profile service for easily managing and handling players' data, and maybe 1 or 2 other libraries, which just makes creating our games significantly easier. Now, even if you're completely unaware of what any of those systems are, none of those are very important to this episode, but if you're wanting to learn more about those systems, I'll leave a link down below in the description to about a 3-part series where you can learn all the specifics about each of those systems. So feel free to go ahead and check those out once you're finished this video. Now, once you have all that set up in Studio, the first step we're going to want to do is actually go and grab a plugin from the toolbox. So we're going to go inside of the View tab, and then we're going to go ahead and enable the toolbox. Inside of the toolbox, we're going to want to swap the category from models to plugins, and we're going to want to search for a plugin called Model Welder. Now, the icon should look something like this, and if we click on it, we can see that this is created by Blumiki Studios, and we can see the date that it was created at. So as long as the date is the same, then that should be enough to confirm that this is the actual plugin that we're wanting. And then, of course, you're going to want to click the Install button. But since I already have it installed, that's not an option for me. And once you have it installed, you should be able to go over to the Plugins tab and then see a little section right here which says Weld Tools. It has 3 buttons: Weld Model, Make Model Primary Part, and Weld Tool, which we'll be using those tools shortly. Now that we have that plugin though, I'm going to go ahead and exit out of the toolbox because we no longer need that. Now, to get started with this, the first thing we're going to do is actually create our coin model. Now, I understand that the coins that people are going to be using are going to most likely be unique to their own game. Sometimes the coin might just be a single part, sometimes it might be a couple of parts to make up a model, it might be a mesh part, or there's a variety of different ways that it could actually be made. But the way that we're going to be creating our coin is by turning it into a model, and by using this method, it actually works with every single other method. Even if you're only planning on using a single part for your coins, you can literally do the exact same thing that we're doing, which will put it inside of a model, but you'll still be able to use your part like you normally would for the most part. Now, even if you are using your own custom coin part, model, or whatever else, I highly recommend that you follow along with us here just so that you can understand how we're creating it, because we do need to create it a little bit of a specific way, and you'll see exactly what I mean. Okay, so what we're going to do is actually first go to the Model tab, and inside of the Model tab, we have a Parts section. We can see the Part button right here, which has an arrow beneath it. Let's go ahead and click that. And the part that we're going to want to go ahead and insert is actually a cylinder. Now we can see that that appears inside of our workspace. And I'm going to go ahead and rename this part from being called part to being called cylinder. It really doesn't matter what you name it, but I just like to be a little bit specific. Then what I'm going to do is just move this up a little bit, and then I'm going to rotate it. So I'm going to flip it over on its side, rotate it 90 degrees. Now that definitely looks a little bit more like a coin. I'll then also resize it as well. So now this is the orientation, and this is the size. I would recommend that you make sure that your orientation is the same, just so that you don't face any issues while going through this video. Now, with the cylinder selected, we're going to go ahead and right click this and click Group as Model. Then we're going to go ahead and rename this to being called coin. Now, this already kind of looks like a coin, but just to make it a little bit more complex, because like I said, some of you guys might have multiple parts to make up your coin, we're going to add a couple of more parts to this just to really help everybody understand how to make this work with your own coins. So I'm simply just going to duplicate the currently existing cylinder, and then I'm going to resize it a tiny bit. So I'm just going to decrease the size by 0.5 on all the axes. So on the X, I'm going to say 0.5, on the Y, I'm going to say 1.5, and on the Z, I'm going to say 1.5 as well. We can see that that's a little bit smaller. Then I'm just going to move that out a little bit, so something like that. And then I'll duplicate that and then move it over to the other side. The size and stuff like that really doesn't matter. This is all pretty much for just demonstration purposes. Anyways, next what we're going to do is just go ahead and select all of these parts and recolor them. I'm going to go ahead and set the color to bronze, and then I'm going to go ahead and rename the model from being called coin to being called bronze. as this is going to be our bronze coin. Now, we're almost fully finished with setting this model up, but the next thing we want to do is actually go to the plugins tab and use the Weld Tools plugin that we just created. The reason for that is because welding parts can be a little bit complicated in Roblox, and honestly, this plugin really helps make it extremely easy and pretty much makes it foolproof and prevents anybody from messing this up. So what you're going to want to do is you're going to want to go ahead and select the model. Then what I like to do is first use the Make Model Primary Part tool, and when you click that, it's going to create a brand new part inside of the model, which is going to be called Primary Part. Now, this part is not going to be visible, but we can actually see that there's now a blue square around our model. So essentially, it just creates a part which is large enough to encapsulate all of the other parts inside of this model. And additionally, if we look at the model's properties, we can see that the primary part property has been set to the part that has just been created as well. Now that our model has a primary part, we're going to use the Weld Model button, which will actually weld all of the parts to the primary part. And the welds are important here because the welds are essentially what keeps the model tied or welded together. Then what we're going to do is select all the parts inside of here, and we're going to go ahead and adjust a couple of more properties. First, we want to set the Can Collide property to false because we don't want any of these parts to be collidable, as we want the players to be able to walk directly through them. Then for the anchored property, the anchor property doesn't really matter. As long as your primary part is anchored, then all of the other parts which have been welded to it will also be anchored as well. But if you want to, you can also set all these other ones to be anchored as well. It really doesn't matter. So with that being said, we pretty much have one of our first coin models set up. Let's go ahead and create another one. So what we're going to do is just select this model, duplicate it by hitting Control D, and then move it over a little bit. Then I'm going to go ahead and rename this coin to be called Silver. I'll go inside of here. I'll select all of the parts. We'll go ahead and change the color of this to be a grayish or just kind of, I don't know, something that looks silver. Now that coin's set up, let's go ahead and duplicate this one more time, move it over, and this time we'll rename this to be called Gold. Of course, we'll select all of the parts, and then we'll just go ahead and recolor them to be a yellow. Cool. So now all of our coin models have been set up. What we're then going to do is go inside of the replicated storage and create a brand new folder, which we're going to rename to be called Coins. Then what we're going to do is select all of these models and drag them inside of this folder. We can then go ahead and collapse that folder and collapse replicated storage because we're done with that. Next, what we want to do is actually set up all of the spawn locations for where we want the coins to appear at. So what we're going to do is create a folder, and we're going to rename this to be called Coin Spawns. Then inside of here, we're going to go ahead and create a brand new part, which we can now see in front of us. Now, let's go ahead and change a couple of properties on the part. First, we're just going to go ahead and change the size, and on all of the axes, we want to set it to 1. So we kind of just want it to be a pretty small cube. Then what we want to do is update the anchored property and set that to true because we do want it to be anchored. And then we're going to set the Can Collide property to false because we don't want the parts to collide with players. And now next what we're going to do is rename the part to be called whatever coin we actually want to spawn here. So let's just go ahead and rename this to be called Bronze because we're going to have a bronze coin spawn here. Then of course we can go ahead and reposition this wherever we want to. So I'm just going to go ahead and put it right there. Then we'll go ahead and duplicate this and move one over a little bit. And then if we want a different coin to spawn, maybe we want a gold coin to spawn, let's go ahead and rename that part to be called Gold. Then we can duplicate it once again, move it over a little bit, and then we can rename this to be called Silver. Now, what we did here is all perfectly fine, but let's say that maybe we want to do a little bit of a different organization method. So inside of here, we'll go ahead and actually add in a brand new folder, which we can rename to whatever we want to. Let's just say that I call this Level 1 because that's how I want to organize my game and my models and stuff like that. So now that we have a folder called Level 1, let's go ahead and duplicate the part called Bronze, drag that inside of this folder, and then just move this around somewhere. You can also do the same thing with Gold as well. So duplicate another coin, drag it into that Level 1 folder, and then just move it over a little bit. Cool. Now we have all of our spawn locations spread out and set up. That means that we can begin scripting. Now, to begin scripting this, we're going to first start off by creating the coins config module, where we'll lay out some information about what coins we actually have in our game, and also how much each coin is actually worth. This can also be a place if you want to specify a cooldown per coin, meaning how long it takes for a coin to respawn after it's been collected, or other individual properties like that. So inside of the replicated storage, inside of the configs folder is where we're going to go ahead and create a brand new module script. Now we'll go ahead and rename this module script to be called Coins. And then of course inside of here, we're going to go ahead and create a variable called local, which we'll set to a table. And we'll also create a variable called shared, which we'll set equal to a table as well. And then finally, we'll go ahead and return the shared table. Now, towards the top of our script, we're going to go ahead and create a brand new type. We're going to say export type so that other scripts which use this module are able to use this type as well. And the type that we want to create is going to be called coin, which is going to be a string union. So we're going to create a string, and our first coin is going to be called Bronze. Then we'll use the pipe symbol to separate the strings. For our second string, we'll go ahead and say silver. Then we'll use the pipe symbol again. And then finally, we'll say gold. So those are the names of our coins. Then what we're going to do is create another type. Now, we don't have to export this type, but you can if you want to. And we're going to go ahead and call this type config. We're going to set this equal to a table. And inside of this table, it's actually only going to have one property. But like I said before, if you want to add other properties to this, you certainly can. The property that we're going to add here, though, is going to be called value, which is going to be a number, as we're going to use this to specify the value of each individual coin. Then below that, we're going to create another type, which we're going to call coin config. We're going to set that equal to a table. Now this table is going to be a dictionary. So for the keys, we're going to be using our coins. And for the values, we're going to go ahead and use the config. So for each coin, we want to specify a config. Then below that, we're going to go ahead and actually create a variable this time, which is going to be a local variable, and it's going to be called config. Then we can specify the type of this to be called coin config, and then we're going to go ahead and set that equal to a table. Now you might be wondering, why are we creating this as a local variable and not making it part of the local table or something like that? And the reason for that is because anytime you add a member to a table, you're not actually able to specify the type of it. So that's why we have to create it as a local variable so that we can use this type, because by using this type, it helps us avoid making mistakes. Okay, now let's go ahead and actually create the config. So like I said, we're going to be using the coin names as the keys. So we'll go ahead and say bronze, then we'll say equals, and then we'll create a new table. And inside this table is where we're going to store our properties at. And the only property that we're going to store is going to be the value property, which for our bronze coin, we're going to set that to 1 because we only want the bronze coin to reward the player with a single coin. Then we'll go ahead and use a comma, and then we'll go ahead and add in the silver coin. So we'll say equals a table. We'll specify the value of this, which is going to be 5. Then we'll go ahead and do the same for the gold coin. So we'll say the value of this is going to be 10. And now we've actually created the config for each of our different coins. Then what we're going to do is between the shared variable and when we return that table, we're going to go ahead and create a brand new function, which is going to be part of the shared table. And it's going to be called getConfig. Now it's going to have a single parameter, which is going to be called coin, and that's going to be of the coin type. And what we want to do is go ahead and return the config for that specific coin. So we'll go ahead and index the config variable with that specific coin. And we can even specify the return type of this function as well. So we can set it to config because we know that's what this function will actually return is the config of the coin. And now with that all being said, that's actually all we have to do inside of this module script. So we can go ahead and close out of it. And we're pretty much done with the entire replicated storage, so we can collapse that as well. Next, what we're going to do is begin scripting this on the server side, which is where most of our logic is going to lie. So to essentially summarize what we want to do on the server side, the server side is going to control basically the spawning system, so individually spawning in all the coins. The collection side of things, so whenever a player touches a coin, the coin gets collected and the player gets rewarded. And then also some other kind of minor things that go along with all of that. So inside the server script service, inside of the services folder, we're going to go ahead and create a brand new module script, which we're going to rename to be called coins service. Then inside of here, we're of course going to create our local and our shared variable, of course returning the shared variable at the end. Then towards the very top of the script, we're going to want to go ahead and create a couple of variables for some different services. So first, we're going to start off by creating a variable for the collection service. And then we're going to want to actually create variables for about 5 more services. Next, we want to create a variable for the player's service. We also want to create a variable for the replicated storage, the tween service, and finally, the workspace. Cool, now we've got all of those variables. Then we want to create a variable for the player data service, which is inside of our services folder inside of the server script service. So we'll go ahead and create a variable called player data service, which is going to be equal to require script.parent.player data service. And then we want to create a variable for one other module, which is actually the coins config that we just created. So we'll create a variable called coins config, which is going to be equal to require replicated storage.configs.coins. And there we go. We now have that module required. Then beneath the player data service module, we're going to create another variable, which the name of this variable is going to be typed out in all capital letters because this is going to be a constant variable, meaning this variable will not change. And this variable is going to be called coin underscore respawn underscore time. And we're going to set that equal to 3. Now we're going to use this variable for how long we want to wait before making the coin appear again to the player. So 3 seconds after the coin being collected, it will be able to be collected once again. Then we want to create one more variable, which is going to be called coins collected. And we want to specify the type of this to be an array, which is going to contain a bunch of models. And we're going to go ahead and set that equal to a blank table. Now, the reason that we're creating this variable is because each time a coin is collected, we're going to go ahead and add it to this table, which will allow us to create a cooldown system. So if the model is stored inside of this table, then that means that the model is currently on cooldown. Otherwise, it can be collected again. And then once it's collected, we'll go ahead and add it to this table. And after 3 seconds or whatever the respawn timer is, we'll go ahead and remove it from this table because it then is off cooldown. So the first thing we're going to do is go ahead and create a brand new function, which is going to be part of the local table. This function is going to be called setupCoins, and it's not going to have any parameters. Now, the first thing we want to do inside of here is create a variable called spawns. And what that's going to be equal to is inside of the workspace, we have the folder, which is called coin spawns. Then what we want to do is use the method called get descendants on that folder to get every single thing inside of that folder and all of their children and all of their children and all of their children. That's essentially what get descendants does. Then what we want to do is iterate through all of those descendants. So we're going to say for underscore spawn, and we can specify the type of this to be a part, even though that's not very accurate. It's still okay to specify the type like that, and you'll see why in a second. Then we'll say in spawns do. So as we're iterating through all of the descendants inside of the coin spawns folder, what we first want to do is make sure that the descendant we're working with is actually a part. So we're going to create a variable called isPart, and what we want to do is check if the spawn variable is a base part. Now, base part covers things like parts, mesh parts, and different things like that. So that's why we're using base part. Now, if the spawn is not a part, then what we're going to do is continue iterating through all the other descendants, because we only want to interact with parts. Now, in order to set up our spawns, what we actually want to first do is set the transparency property of the spawn to 1, because we want to make the spawn parts invisible. We don't want the players to actually be able to see them. It's nice that we're able to see them inside of the workspace while we're working inside of Studio, so that we can easily tell where the spawn locations are at, but we don't want the players to see them. Then what we're going to do is above this function, we're going to go ahead and create another function, which again is going to be part of the local table, and this is going to be called create coin. Now, this is going to have a single parameter, which is going to be called spawn, and that is going to be a part. Then let's go back down to the setup coins function, and after we set the transparency of the spawn to 1, we'll then go ahead and create the coin. So let's go ahead and call that function local.createCoin and pass through the spawn part. Okay, so now when it comes to actually creating the coin, what we first want to do is create a variable called coin type. And we can get the type of coin by using the name of the spawn part. Because remember, we named all of our spawn parts things like bronze, gold, or silver. Then what we're going to do is actually get the coin model. So we're going to create a variable called coin, which is going to be equal to the replicated storage.coins, and then we're going to index that with the specific coin type, and then we're going to go ahead and clone that model. Now, once we clone that model, what we're going to do is actually parent that to the spawn part. So we're going to say coin.parent equals, it also seems like Studio is not able to infer the specific type of what we're cloning here. So we're just going to go ahead and specify the type of that to be spawn, which makes it easier for us as we're scripting. So now we've parented the model that we've just cloned to the spawn part. The next thing that we want to do is actually use the collection service, because we want to use a method of it called add tag to add a tag to this specific model. So the first thing we need to do is pass through the instance that we want to add a tag to, which is the coin model. And then the tag that we want to add is going to be called coin. And the reason that we're doing this isn't going to be apparent yet, but once we begin scripting on the client side, you'll see exactly why we're using the collection service. Essentially, we're using the collection service to make it very easy to differentiate and get all of the parts or models, which are actually a coin, and then work with them on the client side. Like I said, you'll see exactly what I mean once we get around the scripting on the client side. Now, next what we want to do is actually move the model over to the location of where its spawn part is actually at. So what we're going to do is say coin, and then we'll use the pivot to method. And like I said, we want to move it over to where the spawn location is at for it. And to do this, we want to go ahead and create a brand new C frame. And then we're going to go ahead and pass through the position of the spawn location. And that's how we'll move the coin over to where the spawn is at. And next what we're going to do is write the logic for when a player tries to collect the coin. So we're going to go ahead and say coin.primaryPart.touched. And then we're going to go ahead and connect that to an anonymous function. Now, whenever the primary part of a coin is touched, what we want to do is check if a player has actually touched it. So we're going to create a variable called player. And to check if a player has touched it, we're going to use the player service, and we're going to use a method called getPlayerFromCharacter, and then we'll pass through the other part.parent. Because generally, when a player touches a coin, the other part might be a part stored inside of the player's character. So that's why we have to pass through other part.parent, because the parent of the other part would actually be the player's character. And then if we actually do get a player from that, we're going to go ahead and collect the coin, or at least try to collect it. Now, for us to do that, let's go ahead and actually create a brand new function, which is going to be called collect coin. This is going to have two parameters, the first one being a player, and the second one is going to be called coin, which is going to be a model. And then going back to the create coin function, if it is a player who did touch the coin, that's when we're going to go ahead and call the collect coin function that we just started creating. So let's go ahead and call that, pass through the player, and also pass through the coin as well. Cool. Now let's go back to the collect coin function and start writing the logic for this. So whenever a player tries to collect the coin, what we first want to do is check if the coin is on cooldown. So we're going to create a variable called isOnCooldown. And to determine if a coin is on cooldown, what we're going to do is check if the model is already stored inside of the coins collected table. So we're going to say table.find, and we're going to look inside of the coins collected table for that specific coin model. Now, if it is on cooldown, then what we're going to say is return n to stop the function right there. But if it is not on cooldown, then we're going to go ahead and write all the logic for actually collecting the coin. So the first thing we want to do is get the config of the coin. So we'll create a variable called config, and then we'll use the coins config module that we created earlier and use the get config function, and then we'll go ahead and pass through the coin.name to get the config of that coin. Then we can create a variable called value to determine how much currency we actually want to reward the player with based on this coin, which we can get from the config. So we'll say config.value. Then we're going to go ahead and create a variable called action, which will specify the type of this to be playerDataService.stateAction, and that's going to be equal to a table. Then inside of this table, we want to specify the action of this to be update currency, or it could even be update coins, depends on whatever you want to do. And then for the amount argument, we want to go ahead and set that equal to the value because we want to reward the amount of coins to the player based on the value of that coin. Cool, so now that we've created that action, let's go ahead and use it by using the player data service. We'll use the update state function, and then we'll go ahead and pass to the player as well as the action. Cool, so now we're actually handling rewarding the player for collecting the coin, but now we also need to handle putting the coin on cooldown to prevent this coin from being collected again. So to do that, let's go ahead and insert this coin into our table. So we'll say coins collected, and then we'll go ahead and insert that model into that table. So now we've put the coin on cooldown, and then we also need to take it off of cooldown. So we'll say task.delay, and now the amount of seconds that we want to wait is inside of the coin respawn time variable that we created above. So after that amount of time, we're going to go ahead and create an anonymous function, and then we're going to go ahead and make the coin no longer be on cooldown. So we're going to create a variable called index, because in order to remove the coin from the table, we first need to find the index of that coin inside of the table. And to do that, we're going to use a method called table.find. We're going to look inside of the coins collected table for that specific coin. And then we're going to say table.remove. We'll pass through the coins collected table, and then we'll pass through the index that we want to remove from that table. And there we go. We're now putting it on cooldown and then removing it from cooldown. But that's not all that we want to do, because another thing that we want to do is actually make the coin disappear once it's been collected and then reappear once it's available to be collected again. So above the collect coin function, we're going to create another function, which is going to be part of the local table, and it's going to be called update coin visibility. It's going to have two parameters. The first one being called coin, which is of the model type, and the second is going to be called make visible, which is going to be a boolean. So whenever we use this function, what we want to do is tween all of the parts of the coin and adjust their transparency to either make all of those parts visible or no longer visible. So to do this, we're first going to start off by creating a variable called tweenInfo, which is going to be equal to tweeninfo.new. Now, how long do we want this tween to take? Well, we're going to say 0.25, so it's about a quarter of a second. For the easing style, we're going to say enum.easingstyle.linear, and then for the easing direction, we're going to say enum.easingdirection.out. Then we're going to create a variable called tweenProps, which we're just going to set equal to a blank table. Then below that is where we're going to actually add in the property that we actually want to tween. So we'll say tweenProps dot, and now the property that we want to actually change is called transparency. And for the value of this, it all depends on the make visible parameter. So if make visible is true, then we're going to go ahead and adjust the transparency to 0. Otherwise, we're going to set it to 1 to make it not be seen. And now what we want to do is iterate through all of the parts that make up this coin and then adjust their transparency. So we're going to say for underscore descendant in colon get descendants do. Then we're going to create a variable called isPart, because when we're trying to adjust the transparency, we want to make sure that we're only working with parts. So we're going to say descendant is a, and we want to make sure that it is a part. We also want to create a variable called isPrimaryPart, because we don't want the primary part to actually be visible to the players. So if the descendant equals the coin.primaryPart, then we also don't want to use that as well. So now we'll go ahead and create an if statement, and we'll say if not is part, or if it is a primary part, then we're going to go ahead and continue iterating through the rest of the descendants. But now below this is where we know that we have actually gotten a part. And also actually, now that I'm thinking about it, we can specify this as base part, similar to how we did below. There's no reason to make it more specific to the part. I did that by accident. But anyway, now that we know that we've actually gotten the parts that we want to tween, let's go ahead and start tweening each of the individual parts. So we're going to go ahead and create a variable called tween. Then we'll use the tween service, and we'll use the create method on this. And now we need to first pass through the instance that we want to tween. So we'll go ahead and pass through the descendant. Then we need to pass through the tweenInfo. And then finally, we need to pass through the table of properties that we want to tween. So we'll pass through tweenProps. And then we can go ahead and use that tween. So we'll say tweenPlay, just like that. And now that's actually all that we have to do inside of this function. So let's go back to our collect coin function and use it inside of here. So after we reward the player for collecting the coin, and right before, or you can do it right after you add it to the coin collected table, to set it on cooldown, we're going to go ahead and update the visibility of it. So we'll go ahead and say local update coin visibility, then we'll pass through the coin, and then we'll say false because we want to make the coin not visible. Then inside of the task.delay, once we remove the coin from being on cooldown, we'll go ahead and call that once again. Again, pass through the coin, and then this time we'll go ahead and say true because we do want to make the coin visible to all the players. And now with that being said, we're fully finished with creating the collect coin function, and we're literally finished with everything inside of here. Now all we have to do is actually use the setup coins function. So what we're going to do is right below our shared variable, we're going to go ahead and create a brand new function, which is going to be part of the shared table. And this function is going to be called onStart. It's not going to have any parameters. And then what we're going to do is go ahead and call the setup coins function just like that. Now, if you're unsure about what this onStart function does, this is a part of our module framework, which we're using in this episode or for this entire series. So essentially this function is going to run one time as soon as the game starts up. And it's essentially just a nice way of how I like to keep my script structured and organized. So anyway, with all that being said, we could actually hop into our game and begin testing this out just to see what it looks like and if things are working. So we can see that the coins have actually spawned in. We can also see a couple of different coins inside of here. So it does look like this is all working. Let's go ahead and try to collect the silver coin first. So once I collect the silver coin, we do see that my coins have actually been updated. Let's go ahead and collect the bronze coin. We can see that once I collect the bronze coin, my coins have been updated again. And now let's go ahead and collect the gold coin. And when I collect the gold coin, we can see that my coins are also updated as well. And then we can also see that the coins are respawning too. So we can see that pretty much everything appears to be working correctly. But now what we want to do is write some logic on the client side for constantly rotating our coins and making them appear a little bit cooler to players. Now you might be wondering, why are we handling the rotation aspect of this on the client side? And there's two reasons for that. One, whenever it comes to physics, as long as you're able to handle it or it makes sense to handle it on the client side, it's always better to do that over there. The main reason for that is because when it comes to handling the physics on the server side, all of those physics changes need to be replicated down to the client side. So depending on the player's connection or even the server's connection, those changes can appear a little bit choppy or a little laggy, and it just might not look the best to the player. Additionally, when you're able to handle it on the client side rather than on the server side, that takes stress off of the server side. It allows the client to perform some work, allowing the server to have more resources for handling other intensive things that should only be handled on the server side. So to begin scripting this on the client side, what we're going to do is go inside of the start player, inside of the start player scripts, inside of the controllers folder, and then we're going to go ahead and create a brand new module script. Oops, I didn't mean to add that to the GUIs folder. We want that inside of the controllers folder. Now let's go ahead and rename this to be called coins controller. Of course, inside of here, we're going to want to go ahead and create our local variable and also our shared variable, and then return our shared variable just like that. Then towards the top of our script, we're going to want to go ahead and create two variables for two different services. First, we want to create a variable for the collection service. Then we want to create a variable for the run service as well, just like that. Then we're going to go ahead and create a one last variable, which is again going to be a constant variable. So we're going to type this out in all capital letters, and we're going to go ahead and call this rotation underscore speed. And we're going to set that to 180. And essentially, this is the amount of degrees that we want the coin to be rotated per second. So if you want to, you can leave a note here which says degrees per second. Of course, increasing this if you want it to rotate quicker, or decreasing it if you want it to rotate slower. Then what we're going to do is create a function which is going to be part of the shared table, and this is going to be called onStart. Now, it's very simple to animate these coins, or at least the rotation aspect of it. So everything's going to be done inside of this onStart function. Now, what we're going to do is we're actually going to use an event on the run service, which is called heartbeat. And the heartbeat event fires every single frame after the physics simulation has completed. So to simplify this event is going to be called many times per second. So we're going to say heartbeat, and then we're going to go ahead and connect that to an anonymous function, which is going to have a parameter called delta time. And now what we want to do is every single frame, we want to get all of our coin models. And remember how earlier we used the collection service and I said that you're going to realize why we're actually using it once we get onto the client side? Well, right here is why we're actually using the collection service and adding a tag to each of the coin models. Because on the client side, now what we're able to do is create a variable called coins, then we'll use the collection service and we'll use a method of it called getTagged, and then we can specify the tag that we want to get all of the instances of. So the tag that we want to look for is called coin, and this will give us all of the coins which are currently displayed to the player. And what I mean by that is Roblox has implemented something called streaming enabled, which essentially removes models and parts from the workspace on the client side when the client is not near those models, or those models do not need to be displayed to the player. That's of course to help free up memory and different things like that. So by handling all of our models this way, it makes it very easy to use the getTagged method and get all of the coins which are actually currently being displayed to the player. Because depending on where the player is at, coins can constantly be loaded in and out of their workspace. but also since we're listening to the heartbeat event, and this runs multiple times per second, this allows us to not actually have to worry about when those models are being added or removed from the player's workspace, because no matter what, every time we call get tagged, it'll give us all of the coins which are currently actually being displayed to the player. So now that we've got all those coins, what we want to do is iterate through each of the coins. So we're going to say for underscore coin and coins do. Then we're going to create a variable called rotation, which is going to be equal to cframe.angles. And now the axis that we want to adjust is actually the y-axis. So we want to rotate it on its y-axis instead of the x or z. So for x, we'll say 0. Then for y, we'll say math.rad. And then we'll pass through the rotation speed and multiply that by the delta time. And then for the z-axis, we'll pass through 0 because, again, we don't want to affect that. Then we want to create a variable for its current C-frame. So we'll say current C-frame equals, and then we'll say coin.primary part.C-frame. And now also, let's go ahead and specify the coin to actually be of the model type to make it a little bit easier while scripting. So now that we've done that, if we type out primary part, we can see it's automatically suggested to us. And then we'll say .cframe just like that. And now let's go ahead and actually rotate the model. So we can do this by saying coin pivot to, and then we're going to multiply the current C-frame by the rotation. Now, one pretty important thing to keep in mind is that depending on how you actually created your coin, you may need to use a different axis. Essentially, we inserted a cylinder part into our game, and then we rotated that a little bit. So that's why we're modifying the y-axis. But if for some reason your coin is rotating on the incorrect axis, then you can simply just go ahead and copy this part right here, set the y to 0, and then paste it right here for z, for example. Or maybe you need to use the x-axis, so then go ahead and paste that right there. But for us, we want to go ahead and use the y-axis, so that's why we're going to leave it just like that. Now, if you want to know more about the specific math and logic that we're actually using here, I'm not going to lie, I've used this logic a lot when I've been scripting, but my understanding when it comes to C-frames, angles, and any of the math related to those topics, I'm very ignorant towards, and I really don't have a good enough understanding to explain that to you. So I went and asked ChatGPT, and this is the explanation right here. If you want to go ahead and pause the video right here to read the explanation, you certainly can. Or feel free to copy the code and paste it into the ChatGPT and ask it to explain it yourself. Anyways, with all that being said, we're finished with writing the controller script, so we can go ahead and close out of that. We can also close out of the service script as well, start up our game, test this out, and see if they're currently rotating. And now, when we start up our game, we can see that all the coins are actually rotating. So let's go ahead and collect the coins once again. We can see that they're no longer visible when we collect them, and then once they're visible again, they are still rotating. So this appears to be working perfectly. But anyways, ladies and gentlemen, that's going to be it for this episode. As always, if you did enjoy, make sure you smash the like button. Please leave a comment down below, letting other people know that it did work. I and they really do appreciate it. It helps everyone out. And as usual, if you want to gain access to all the scripts and the game file that we made during this episode, as well as a ton of other assets, you can visit MonzterDev or my Patreon, link down below in the description to both of these. You can gain access to a ton of assets to easily create your next Roblox game, as well as support me in creating all the content that I create. Anyways, with all that being said, I hope that you guys have a great day, and I'll see you guys in the next episode.